All right, guys, welcome back. So we are going to look at lesson 9.3, rotations. I'm not going to remind you of this every single video, but definitely today, now that you've kind of had 2 days of school, you've had the weekend, and for those that maybe didn't jump on the Zoom call those first few days, I just want to remind you that the goal is at the start of your class time, if you have no questions from your homework, right? You checked it, it's perfect, you're like, got it, next. Around when your class time starts, just literally jump into Canvas, go to modules, open this video. If you want to fast forward, you can fast forward. If you want to pause it, because I talk fast, pause it. Like whatever you need, it's at your pace. And then just work on the homework during that class time, right? But if you had questions, like let's say you did the homework and you were just lost or you just couldn't figure out one of the problems, then around the start of class time, I'm gonna manually open up that Zoom, right? So you see in your thing, it says like home, grades, modules. If it says Zoom, my Zoom is open. You click it, open it up, you'll be able to log right in. But my plan is to only keep that open for as long as there are questions, right? So I imagine if you log on within like the first 10 minutes of class starting, that's when you want to do that, right? Because I'm going to start going over questions, and possibly once you get to that 15-20 minute mark, if nobody else is on that has questions, they've all logged off to get working on their work, I'm going to go ahead and turn the call off, right? So I'm not going to like turn it off right away, like, oh, 3 minutes, nobody's here, close it. I won't do that to you, but I also want to respect my time just like I'm trying to respect your time, okay? So if you have questions, prioritize getting onto that Zoom call at near the start of class so you can do that and then get off and get to work, right? But again, if you do not have questions, don't waste your time with the Zoom call. Skip it, go right into modules and keep going, okay? I'm not going to repeat that a lot. I just wanted to pause for one video and make that known. Okay, so we're looking at rotations, and rotations we're going to look at over the course of 2 days. The first day, I guess if you're going to call it one easier, one harder, the easier one is in a rotation is when they are rotating around what's considered the origin, right? So that 0, 0 point, and rotating is that the point is rotating around the 0, 0. Why we consider this easier is because there's going to be a relation in the XY movement of the original point and the location that it ends up. Whereas when we are going to be looking at something that is not around the origin, as it moves around, it starts to have some very weird points, right? Not crazy complicated, but it is different, and that's why we separate this into 2 days. So the main idea is that a rotation, of course, has a center, and we're going to start that rotation being around the origin. You can technically rotate any direction, any amount of angle that you would want. This original one is 120. But for the purpose of this class, we're going to just be looking at those perfect quarter turns, right? So we are going to turn 90 degrees, 180, 270, or all the way back around to 360. A quick notation thing you may have noticed on the homework that I want to point out, whenever we're talking about a translation, they tend to use a T and then write what the translation is. Like 2 comma 4, that meant add 2 to the X, add 4 to the Y. When we got to reflections, sometimes they'll use like REF, or if it says something that kind of implies reflection, you'll know it. But they like to use the letter M, not 100% sure why, but if it says like M for reflection over, X equals 1, that we know that that means a reflection across that line. And then now we're going to look at rotations, and they do use the letter R. Most of the time, you're going to then see what looks like a 0 or an O, and that's standing for that this rotation is around the origin as opposed to something else. And then it will usually tell you an amount. So let's say it says 90 degrees. It's also possible for it to say rotation around the origin of negative 90 degrees. So I want to make sure we talk just real quick about like what's the difference in going positive versus negative. So although this might seem backwards, what's considered the normal positive direction is counterclockwise. And I know you hear the word counter, it sounds like opposite, and on some level it is, right? A clock, tick, I'm trying to look at it from your angle, right? It's like tick, 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 like that's how a clock goes. But in coordinate planes, the order of the quadrants, 1, 2, 3, and 4, if you follow them, they follow like a capital C, and this is going counterclockwise, right? The clock is going to tick this way, but in math we read the quadrants the other way, and so because of that, we consider that direction that is not like a clock. So the counterclockwise is considered the positive or normal rotation. So if a problem just says rotate 90 degrees and gives you no information, then we know they're going counterclockwise. If the problem says rotate negative 90 degrees, we know they will actually want to go clockwise 90 degrees. Okay, so just kind of be aware of that and look at that vocabulary, look at that positive versus that negative. So if it says in the words counterclockwise a certain amount or clockwise a certain amount, follow what it's saying. But just a general rotation with no other indication than positive or negative, that's how we can tell. All right, let's go ahead and look at some of the rules. And I'm gonna actually show you how to think about this in a way that doesn't require you memorizing these rules. Because there's nothing wrong with these rules. They're not like intrinsically this most difficult thing to work on, and especially if you have the rules written down, great. But like, let's fast forward a year or two from now. You're in your junior year and you're taking, let's say, the SAT. They're not going to give you these rules, and chances of you having these memorized still is basically non-existent. So a lot of what I like to do is show you how to think about a problem that might not need this, but I will also point out how to use them because there are some situations where, to me, the rule is really quick. Other times, just kind of knowing what to look for and how to execute is just as important and just as easy. So what I mean by that, just to show you one example of a rule, if they start with the point 5,2 according to this problem, and we want to rotate a 90 degrees counterclockwise, since it doesn't say, it mentions that the rule is negative y comma x. And how I would apply that rule is I would say, okay, looks like they've switched the order of x and y, so I need to switch the 2 and the 5. And also the y value, or the first coordinate value now, is going to be opposite sign of what it currently is. So if it's currently a positive 2, it's at negative 2. And then when I go to plot that point, negative 2 comma 5 is the location of that. All right, now if you don't want to use the rule, it's hard for me to do on the board because I can't physically take my board and rotate it, but you can. So I'm going to kind of be silly and goofy, like literally like turn my head, because I can't turn my board. But if I want to take this and go 90 degrees counterclockwise, the regular direction, that means I'm turning in this way. And so how I would look at this is I go, okay, the original point's here. I know generally that point's going to show up over here. So what that means is I almost need to like read where this point is at. So this point is at over 5 up 2, and then I turn my head or turn my paper 90 degrees, and I'm literally reading this like this is my new XY graph. So it's like I turned the whole board, and now I'm staring at this, and I'm gonna go, okay, originally it was over 5 up 2, great, over 5 up 2, and I'll get where that point is at. So we'll show you that again on another example, but that's kind of the difference in just counting it, turning the paper and counting it, and then just coming back and seeing where the point landed, as opposed to applying the rule. Again, you can see where the rule might be easier to do, but eventually you probably don't have that memorized, and this is a way to kind of do it without the rule. Okay, if you can't see them super well in your video, the rule for 180 degrees is negative x comma negative y, and the rule for 270 is y negative x. And if you're really gonna just be obsessed with using these rules, if they, however, say instead of counterclockwise, going clockwise, you kind of have to sort of figure out which rule makes sense. And what I mean by that is if a point is going to go 90 degrees this direction, that would be mathematically the same thing as going 270 degrees the other direction. So that's kind of where we're at. So if I say 90 degrees counterclockwise, or I said 270 degrees clockwise, they would end up being sort of the same. Understandably, there's some confusion of trying to think about those words, and that's where I really recommend kind of the turn your head, turn the paper method of attacking these problems. Okay, so let's do one. This one is saying, let's pay attention to where point T is at. I love it when the smartboards decides to be goofy and uncooperative. Think about your life. Get it together. All right. Okay, sorry guys, I put the smartboard in timeout and I think we're back to working again. So this one is wanting us to refer to the point T, which is right here, which is originally located at positive 1, 2, 3, 4, 5, 1, 2, 3. And if I'm not using the rule, I'm going to pay attention to which way it's asking me to turn. Now it says 90 degrees counterclockwise, which does mean this direction. Again, if it doesn't say that, then the fact that this is positive would automatically tell me to go this direction if it doesn't specify. So again, I know that we're trying to turn this point over here, so I'm going to basically turn my head, because I can't turn the smartboard, right? You could turn your paper, but now I'm going to read this like this is my new X and Y. Like that's my origin still, but I'm reading the X and Y now that I've turned my head. So if this is originally +5, +3, when I turn my head, I'm going to count +1, 2, 3, 4, 5, +1, 2, 3, and get that point is approximately there. Now to answer the question, I do have to step back and look at the actual X and Y axis to read that this point is at -1, 2, 3, up 1, 2, 3, 4, 5. So -3, 5 is answer choice C. Now, if you did want to use the rule, you would remember that your rule for 90 degrees counterclockwise, if you happen to have that written down, the rule is -y, x. And so if I have access to that rule, then I notice that X and Y have flipped places, so 3 and 5 will flip places, and this first one is going to be opposite sign from what it is. That would be using the rule. So you can see where the rule can actually be faster, but I'm going to warn you that tomorrow when we're not using 0, 0, the rule actually becomes way more complex, and that's why I'm going to encourage you to kind of try the turn in the paper thing, possibly knowing what the right answer is supposed to be with the rule. Try doing the turn the paper and see if you can get the same answer that way, because once you do that, you'll be able to do this forever and not have to rely on memorizing a rule. Okay, one more example like that. This time it wants me to focus on point Q, and it's already got it labeled for me as 4, 5. It does mention, again, 90 degrees counterclockwise. Counterclockwise, of course, is standard if it doesn't say, but it chose to specify. So we're going to turn this direction. So again, I know we're going over here, so I know that I need to kind of look at this paper sideways. So 4, 5 is over 4, up 5, over 4, up 1, 2, 3, 4, 5, and then read off where that point is, looking at it straight on like normal again. -5, up 4. Okay, or like I said, if you know that the rule is flip these two and change that sign, great. But again, keep in mind, that's just for 90 degrees. You would have to know what that rule is for all of the possible ones, not just flip it, change the sign. Like that's not always going to be the rule for every single turn. Okay, so here's one where it wants me to take 4 points, rotate it once 90 degrees and another time 180 degrees. So this is one of those small times where knowing the rule might be faster if I need to do it to 4 points, so that way I can just kind of quickly flip them all and replot them. So I will show you again just both ways on that and just work that out on this first example. So the original point is -2, 4, that's A. B is -4, -1. That's B. C is at -1, 2, 3, 1, 2, 3. And D is -1, 0. And if I were to connect those carefully, there's my quadrilateral, four-sided, diamond-ish looking shape. So where does this end up going? So we're looking to go 90 degrees about the origin. Again, notice it doesn't say counterclockwise or clockwise here, so we always understand that to be counterclockwise, again, when it doesn't say. So I'm gonna go in letter order. And like I said, 90 degrees counterclockwise is trying to turn my head this way, one space. So if A is normally at -2, up 4, I'm going to turn my head and go -2, up 1, 2, 3, 4. And that's my new A prime. The original B, looking at this where it's currently at, is -1, 2, 3, 4, down 1. So turn my head, -1, 2, 3, 4, down 1. Okay, B prime. C, -3, -3. Turn my head, -3, -3. And lastly, D prime is currently left 1, do nothing. So turn my head, left 1, do nothing. And if I were to connect these, you should get the same quadrilateral, right? This is considered an isometry, meaning it is not changing its size or its shape because it is a symmetrical change. Sometimes they'll also use the word rigid in reference to it didn't change size, it just moved. And so we have kind of clicked one space, 190-degree turn of this. Had you practiced the rule on this, just to show you the other option real fast, here we learned that you flip the order of them, change the sign of the first. Flip the order of them, change the sign of the first. Flip the order of them, change the sign of the first. Flip the order of them, and you can't change the sign of 0. And so if you look, just to kind of show you one at random, -4, -2 is where that landed. Or another one, +3, -3, +3, -3. So again, just to highlight the difference in using the rule versus not. But again, you'll notice that switch them, change the sign is just the 90-degree rule. If I wanted to do the 180 rule, that one is -x, -y. So for that problem, I'm actually not changing the order of them at all, but I am changing both of their signs. So for this one, it would just become +2, -4, +4, +1, 3, 3, or 1, 0. And that would be the rule method of doing those points. And again, you can see how that is fast if you have access to the rule. If you don't, and I'm only going to do this on one of these points, let's take the point -2, 4. -2, 4 is the original A. Going 180 degrees, it doesn't really matter which way you go 180, you're going to land at the same point. It's like telling me turn all the way around. Well, whether I went this way or I went this way, I end up facing the same direction. You'll also notice on the homework, sometimes instead of that being rotate 180, they might call that H for what's considered a half turn. So if you ever see that H around the origin, it's another way of saying rotate 180 degrees. So rotating 180 degrees, if I'm originally going -2, 4, and I have to do this paper twice, right? So click, click, and now I'm literally like upside down, right? I can't do this on the smartboard, but on my paper, I would have just been like, turn it around, way easier. But I'm trying to go -2 up 4. Once I've turned my paper over, -2 up 4 ends up here. Okay, and just to kind of confirm myself, that ended at 2, -4. Yes, that matches the rule way that I did it. Okay, I feel comfortable that I'm doing that correctly. All right, that's all I've got. You kind of notice we are hitting these rules in sort of the order of difficulty, so sliding them around is not so bad. Flipping them is the next one, and now twisting them gets a little bit more tricky. So we're kind of going in order. We will also continue to practice this tomorrow with a little bit of a change as far as it's not always using 0, 0 as the spot that it turns on. Okay, well, good luck. Check that homework, and of course, log on if you have any questions tomorrow.